morning, students. 9th class second chapter name is polynomials and factorization. So in that subtopic third, that is the degree of the polynomials. So in that we plan to discuss 6 points. Among that, fourth point is the types of polynomials with one variable. Once again I am reading the title, which is the fourth point, that is types of polynomials with one variable. Mainly we can focus x variable. Note this point, we can concentrate the variable is x. So these types of polynomials with one variable we categorize two parts. One is a, one is b. Actually, what is a? A is the title based on the degree concept. So we can say the types of polynomials with one variable x. The variable is x based on the degree. So students, this format, table format clearly observe. One side serial number, next polynomials, degree, its name and examples. What is first one? Yes, first one is a. It is one of the real number which is treated as a 0. A is one of the real number, it should be 0. Right, here a can be written as ax. Why? Because if a is equal to 0, 0 into x, that means 0x. So 0x is one of the polynomial only. So it's a degree. Not only 0x we can express in many ways. 0x square, 0x power 3, 0x power 10. However we can express 0. So that reason it has way of expressions different there. We can express 0 is many ways. Based on that it has many degrees. So that reason we never give unique answer as the degree of the 0. So that reason the degree of the 0 is not defined. So its meaning is a is one of the real number where it is considered 0. It has not defined. Its degree is not defined. So best example you feel that 0. In this first concept, a is equal to 0. In a sense we are talking about 0 only, which is called as a real number. That 0 can be expressed in many ways. Just I shown here 0x square, 0x power 3, 0x power 10. Such a way we can express many ways. Based on that it has many degrees. But thing is we never give unique answer of the degree of the 0. So that reason its degree is not defined. So what about 0? In this polynomial we can call 0 as a 0 polynomial. 0 is called, 0 is one of the real number which has no degree. Its degree is not defined. Its name is 0 polynomial. So best example is 0. You observe carefully about first point. 0 is one of the real number. Its degree is not defined. So that 0 is called 0 polynomial. This is one example. Let us go with the second concept. Second thing, for all a belongs to R. Nothing but for every a as a real number except 0. Sorry, except not equal to 0. Already 0 work almost here completed. So that's why in second round don't concentrate 0. That means a is not equal to 0. A is not equal to 0. Except this you can take a as any real number. So then their degree is 0. Suppose okay, right? Suppose here take 5. 5 can be written as 5 into 1. It can be written as 5x to the power of 0. So what happened, tell me? 5 is one of the real number. It's a degree. It is a numerical expression. We converted to algebraic expressions. After that we found its degree as a 0. Nothing but In second case, we are taking real numbers except 0. Their degrees are always 0 only. Such type of polynomials are called, it is polynomial number. 0 is can be written as 5x to the power of 0. So that reason it is one of the polynomial. So such a polynomials degrees are always 0. Such type of polynomials are called constant polynomials. Just example 5, not only 5, you take any real number except 0. This is about second point. Let us go with third point. What is third point? AX. Structure observe AX or AX plus B. These both structures observe. In this one condition, A should not 0. A is not equal to 0. And here A and B are belongs to constant. C indicates the constants. So A comma B are constant, A not equal to 0. When these two conditions are applicable of these two, then concentrate their degree. Its degree is 1. Its degree is however 1. Already we discussed the previous video how to find the degree. So it's a degree 1, its a degree is also 1. In a sense, the polynomials which are in the form of AX or AX plus B form under these two conditions. Such a polynomial's degrees are always 1. 1 degree of the polynomial, such a polynomials are called linear polynomials. One example, 2x, 5x minus 1. Just I gave two examples. One is 2x which is related to ax. One more is 5x minus 1 which is related to ax plus b. Its degrees are 1. So that reason these are called linear polynomials. Linear in a sense you just feel that unique 1. Now let us go with the fourth point, that is ax square plus bx plus c. So in these two conditions are there, a is not equal to 0 and a, b, c are belongs to constants. So now tell me what about its degree? Its degree is 2. So that reason this is called quadratic polynomial. Once again, this is called quadratic polynomial. This is the best example. Okay, students? Okay, now let us go with the fifth one. What is fifth one? Ax cube plus bx square plus cx plus d. Here again two conditions are applicable. A is not equal to 0. At the same time, a, b, c, d are belongs to constants. So however its degree is 3. Already I mentioned that. So that's why this polynomial is called cubic polynomial. This is one example. Now let us go with the sixth point, that is ax to the power of 4 plus bx power 3 plus cx square plus dx plus e. Again two conditions are applicable. What are those two? A is not equal to 0. At the same time, a, b, c, d, e are belongs to constant. So however its degree is 4. So degree I wrote 4. So this is one kind of polynomial. Its degree is 4. Based on that, this is called fourth degree polynomial. This is one example. Okay, now let us see last point, that is seventh. So in this, a n x to the power of n plus a n minus 1 x to the power of n minus 1 plus a n minus 2 x to the power of n minus 2 plus dot 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 a1x plus a0. So here also two conditions are applicable. One is an is not equal to 0. At the same time, an minus 1 dot dot dot. These are belongs to constants. And whatever the degree of this one, its degree is however 1 only, n only, So this is one of the polynomial whose degree is n. So that reason it is called nth degree polynomial. Once again, it is very important. It is one kind of polynomial whose degree is n. Such a type of polynomial name is nth degree polynomial. there is empty place because we cannot give the proper example for that. Okay, now students, these are details about the types of polynomials with one variable based on the degree, right? No doubts, I think so, right? Okay, students, let us go with the second, that is B. So types of polynomials with one variable, that is particular x only, but thing is based on the number of terms concept. Okay, right? Let us see one by one. Serial number, polynomials, number of terms, its name, few examples. So there are four things are there, concentrate. A, which is called as real number. A is one of the real number, that's it. AX. In this AX, A is one of the real number only. You choose whatever that real number. That is your concern. Thing is, A and AX. In these two polynomials, observe carefully. How many terms are there? Number of terms. Here one there. Here also one only there. No? These two are best examples of polynomials where A belongs to real number. But thing is, in these both polynomials, how many terms are there? One. So one term there. So the polynomial which contains only one term, is known as monomial. This is 9 is one of the monomial. 5x also one of the monomial. Monomial definition is very clear that the polynomial which contains only one term is known as monomial. These are two examples. Let us go with the second. What is second? Ax plus b, where a comma b belongs to constants. Once again, ax plus b, where a comma b belongs to constants. Okay, this is one of the polynomial only. Okay, students. But in this polynomial, how many terms are there? Two terms there. One is ax, one is b. Yes, no? So number of terms, two there. The polynomial which contains two terms is known as a binomial. So that reason this is a binomial. So this is one example based on this one. Right? Let us go with third one. Ax square plus bx plus c, where a, b, c are belongs to constants or else numerals. But thing is, this is one of the polynomial whose number of terms are 3. Here how many terms are there in this? Ax square is 1, bx is second term, c is third term. 1, 2, 3. It has 3 terms. So that reason, the polynomial which contains 3 terms is known as a trinomial. So this is one example which is related to this one. Here also 3 terms there. X square is first term, 5x second term, 6 is third term. It contains 3 terms. That's why its name is polynomial. Now let us go with fourth. This is the last one. Ax power n, ax power 3 plus bx square plus cx plus d, where a, b, c, d all belongs to constants or numerals. But thing is, a special situation is, in this how many terms are there? Actually 4 terms there. 1, 2, 3, 4. But we have to focus that the polynomial which contains more than 2 terms. Carefully, students. Actually it has 4 terms. But you should not concentrate 4 terms. You should focus on the polynomial which is having more than 2 terms. Yes, exactly. In this, how many terms are there? More than 2 terms only. In this, more than 2 terms there, no? Actually, 4 terms are there. 4 terms there. But however, it contains more than 2 terms. Correct only, no? Yes, exactly, it is correct only. This is one of the polynomial which contains more than two terms. Such a polynomials are called multinomials. Okay. This is one example, observe. See, a multinomial side I took this also. Ax plus b, where a is not equal to 0. This is also called multinomial only. Because we mentioned there two or more than two terms. Sorry. A small mistake there. Two terms are more than two terms. Just yes, see, ax plus b. How many terms are there in this? Two terms there. No? So that reason this is called multinomial also. Note, very very important that it is binomial as well as multinomial also. Now let us go with this one. Ax square plus bx plus c, where a is not equal to 0. In this, how many terms are there? More than two terms there. So that reason this is also one of the multinomial only. But important notice that it is one of trinomial actually. So trinomial, even though every trinomial is one of the multinomial. So based on these conditions, so what is the main condition to define the multinomial? Multinomial is nothing but the polynomial which is consists two or more than two terms is known as a multinomial. 1 second, students. 1 second, be cool. The definition of multinomial is the polynomial which contains two or more than two terms. The polynomial which contains two or more than two terms is known as multinomial. 1 second, this observe. Number of terms column observe. Two terms are more than two terms. Where? In a polynomial. Nothing but the polynomial which contains two terms or more than two terms is known as multinomial. This is one of the multinomial. This is one of the multinomial. This is one of the multinomial. So few examples are there. 2x plus 1, x square plus 5x plus 6. These three also best examples of multinomial. Okay, na? I think almost we discussed about, based on the number of terms, we discussed few types of polynomials. The previous just now we discussed based on the degree few more types of polynomials. Okay, my students, right? I think there is no doubt. The title, the types of polynomial with one variable, mainly we concentrated x variable. So almost it is completed beta, right? Okay, na? Right. Okay, students. Based on this fourth title, types of polynomials with one variable, mainly x, we have to discuss the special points one by one. Let us see. One is polynomials. Polynomials maybe multinomials. Multinomials. Once again, polynomials may be multinomials, but every multinomial need not to be polynomial. So, to believe this statement, I want to give clarity about it. Polynomials, I want to take, suppose ax plus b, ax square plus bx plus c. Now ax power 3 plus bx square plus cx plus d. Like this, you can write many. These are polynomials. Maybe they are multinomials also, or multinomials also. Multinomials also. Why? These three also best examples of the polynomials, no doubt I think so. Why they are multinomials? Because of here more two terms there. That's why it is multinomial. Here more than two terms are there. That's why multinomial. Here more than two terms are there. That's why multinomial. Actually, multinomial concept is right. The polynomial which contains two or more than two terms is known as a multinomial. Right now, just now we discussed. So based on that, this is multinomial. This is multinomial. This is multinomial. Before that, they are polynomials. Nothing but polynomials may be a multinomials, no doubt. But every multinomial, for example, suppose x square x power minus 2 plus 3 there. 3. Now I want to give one more example. X square plus x to the power minus 1 plus 4. In such a way we can write many, which are called as a multinomials. Yes, in this how many terms are there? 2 there. Here more than 2 there. In such a way we can write many multinomials. These are multinomials because of 2 terms there, more than 2 terms there. That's why these are multinomials. But see, every multinomial, these two are multinomials now, but need not to be polynomials. Those are not polynomials, or not polynomials. So to believe this statement, the small example observe. These are polynomials as well as they are multinomials. But every multinomial, just take these two examples. These two are multinomials only, but not polynomials. No. So you believe that polynomials may be a multinomials, but every multinomial need not to be polynomial. This is first special point to us. Okay, no doubt I think so. So let us go with the second point. That what is second point? Right. The second point is linear polynomial. Linear polynomial may be monomial or binomial. You believe this statement also. So behind that reason, so to understand this sentence or statement, to believe, so the situation observe. Linear polynomials. I want to write linear polynomials. Yes. ax plus b. Here a is not equal to 0. Here a is not equal to 0. So I took two linear polynomials. This is a linear polynomial. This is also one of the linear polynomial. So how to decide those are linear polynomials? Simple. It's a degree 1. 1 degree of the polynomials are called linear polynomials. Just now discussed. So that's why this is a linear polynomial. This is also one of the linear polynomial. Behind that reason, it's a degree 1. It's a degree 1. Okay. But think what happened? It is a linear polynomial. How many terms are there in this? One term there. That's why it is a monomial. Here how many terms are there? 2 there. That's why binomial. I think okay na? Here this is called monomial, this is called binomial. In a sense, before that these two are linear polynomials. Linear polynomials may be a monomial or binomial. Okay na? Okay students? Alright, done. Good evening students. We are learning about second chapter. Its name is polynomial and factorization from 9th standard. So in that, third subtopic is, that is 2.3. Its name is degree of the polynomial. Under this title degree of the polynomial, we made 6 points. Among that, 5th point is minimum and maximum terms of a polynomial. Once again, minimum and maximum terms of a polynomial. Okay, let us see one by one. Observe carefully. Serial number name of the polynomial and particular conditions and the number of terms. So let us go with the first one. Zero polynomial. Zero polynomial, best example is zero only, no? Yes. It is one of the real number. R indicate real number. A is belongs to R. A is one of the real number where A is considered zero. A is belongs to real number where A is equal to 0, nothing but we are taking 0 only. So, right here 0 written. One more. In that 0, okay, let it be. Next, second point is constant polynomials. Nothing but I took A. Constant polynomial, best example is A. Where A is belongs to real number, A is not equal to 0. Here A is equal to 0, here A is not equal to 0. So difference observe carefully. In a zero polynomial, condition of A is 0. A must be 0, but here A is not equal to 0. This difference once observe. Nothing but you choose any real number except 0. Here 0 must be. Here 0, here except 0. Thing is, that's why we written here 0. Here just A. A is nothing but one of the real number. But except 0. Okay, anyhow, 0 polynomial, constant polynomial. Basic ideas, basic concepts. And through that we got 0 polynomial, best example is 0. And constant polynomial, best example is A, where A is a real number, where A is not equal to 0. Okay, anyhow, in this 0 and A, how many terms are there? Number of terms, 1 only. You remember that, you conclude that, you try to understand that the number of terms in a 0 polynomial and constant polynomial is always 1 only. Right, next. Let us see third one. Its name is linear polynomial. See, linear polynomials, we want to discuss two things here. Ax, it is one of the linear polynomial. So, where A is belongs to real number, A is not equal to 0. So, based on this Ax, it is one of the linear polynomial. So, conditions are A is belongs to real number, A is not equal to 0. At the situation, Ax, output is Ax. In this Ax, number of terms tell me. 1 only, no? Here how many terms are there? 1. Now linear equation side, second one observe, that is Ax plus b. Okay, now? First we discussed the Ax. Now second situation we are discussing Ax plus b, where A comma b are belongs to real numbers. So there are two situations. Case 1, A not equal to 0, this term A there, no? A not equal to 0, B is equal to 0. A not equal to 0, B is equal to 0 in a sense. While substituting B value is 0, then what will happen, tell me? You will get Ax only, no? In that Ax, how many terms are there? Number of terms, 1 only. One more case, A not equal to 0, B not equal to 0. Nothing but A not equal to 0, B also not equal to 0. Through that, you will get Ax plus B only, no? So this is one of the linear polynomial. This is also one of the linear polynomial. Linear polynomial may be a monomial and binomial. Monomial or binomial. So anyhow, Ax, it is one of the linear polynomial. Ax plus b, it is also one of the linear polynomial. But our target is number of terms in that. In Ax, number of terms 1 there. Ax plus b, in that number of terms 2 there. Nothing there to discuss about linear polynomial. Very clear. In a linear polynomial, minimum number of terms 1 beta, See, year 1, year 1, year 2. This is a related total linear polynomial concept only. Minimum 1 term, maximum 2 term. Once again, in a linear polynomial, minimum terms are, see, minimum terms are 1, maximum terms 2 there. I think, okay na? You got clear? Let us go with fourth one. What is fourth quadratic polynomial? Its a general form is ax square plus bx plus c. In these 4 conditions there, based on the conditions, we have to discuss the number of terms, right? First condition, a not equal to 0, b is equal to 0, c is equal to 0. B is equal to 0, C is equal to 0, in the sense the 2 terms are going to convert to 0 only. So ultimately what is the outcome? Ax square only, no? So in this how many terms are there? 1. Condition 1. Let us go with the second condition. A not equal to 0, B not equal to 0, C is equal to 0. Nothing but in this C is considered 0. Then what will happen, tell me? The result is Ax square plus Bx only, no? In this number of terms 2 there. So third situation, A not equal to 0, B is equal to 0, C not equal to 0. Nothing but B considered 0. Then what is the outcome? Ax square plus C. Here written already Ax square plus C. In this number of terms again 2 only. So last case observe. A not equal to 0, B not equal to 0, C not equal to 0. Nothing but these 3 also not considered 0. So it is the situation. Our outcome is as it is only, no? Our outcome same only. In that, how many terms are there? 3 there. So now tell me. In a quadratic polynomial, minimum how many terms are there? Minimum figure of the year 1 there, 2 there, 2 there, 3 there. Minimum figure is 1. Nothing but in a quadratic polynomial, minimum terms 1, maximum terms 3. I think got it. Once again, in a quadratic polynomial, minimum terms are 1, maximum terms are 3. Okay, right. Okay, students, let us see fifth point, that about cubic polynomial. Cubic polynomial general structure is ax cube plus bx square plus cx plus d. So the conditions observe carefully. First one, a not equal to 0, b is equal to 0, c is equal to 0, d is equal to 0. If this is 0, this is 0, this is 0. All is 0, you know. What is the result? Ax cube only. I written already. So in this number of terms 1 there. Let us go with second case. A not equal to 0, b not equal to 0. This is not 0, this is not equal to 0. Remaining 2 terms are 0. Nothing but what is your outcome? This is your outcome only, no? That is why ax cube plus bx square. In this number of terms 2 there. Third case, a not equal to 0, b not equal to 0, c not equal to 0, d is equal to 0. Nothing but this is total 0. What is the remaining answer? When it is considered 0, what is the answer? Ax cube plus bx square plus cx only, no? Written. In this number of terms 1, 2, 3, right? Fourth one, a not equal to 0, b not equal to 0, c is equal to 0, d not equal to 0. Now it is became 0. Now what is the outcome? Ax cube plus bx square plus d only, no? Yes, 1, 2, 3. In this number of terms 3 there. Now last, that is fifth. A not equal to 0, b not equal to 0, c not equal to 0, d not equal to 0. Nothing but as it is the result, you know. So in this number of terms, tell me 4. See, 1, 2, 3, 4, right? Through this smart work, we conclude one thing, that in a cubic polynomial, minimum terms, tell me, minimum terms, here 1 there, 2 there, 3 there, 3 there, 4 there, minimum terms 1. So maximum terms, tell me, 4. Once again, in a cubic polynomial, minimum number of terms are 1, maximum number of terms are 4. Okay, na? Right. Okay. Now see special points. Special points. And in a sense, previously we discussed a few things. things. Based on that, we have to list out the special things, special points. Once let us say one by one. Zero polynomial. In this, minimum terms 1. Zero polynomial, minimum term is 1. Maximum term is also 1. Now, commented. Let us go with the second, that is constant polynomial. In that constant polynomial, minimum term 1, maximum term 1. Got it? Now let us go with third one. Linear polynomial side, minimum terms 1, maximum terms 2. And one more. Fourth one, observe. Quadratic polynomial side, observe. Minimum term 1, maximum term 3. Fifth one. Cubic polynomial side, minimum term 1, maximum terms 4. So sixth one, fourth degree polynomial. So minimum however 1. Nth degree polynomial side minimum 1. But how to list out this one? How to list out this? Small technique, observe carefully. Linear polynomial. Linear in a sense, one degree of the polynomial is called a linear polynomial. Linear in a sense, we can treat 1 nothing but 1 degree polynomial. Here 1 is important to me. So in this maximum terms, how many are there in linear polynomial? 2. Nothing but this I want to write 1 plus 1. This 1 indicates the degree of the linear polynomial. First one is indicate that degree of the polynomial. Plus 1 however come. So plus 1 plus 1, answer is 2. Similarly, quadratic polynomial, nothing but second degree of the polynomial is called a quadratic polynomial. So in this 2, it's a degree of the quadratic polynomial plus 1. We got maximum terms in the quadratic polynomial, 3 only. So cubic polynomial side nothing but the polynomial which degree is 3 is called a cubic polynomial. So in this, it's a degree, tell me 3 plus 1. We got 4. Nice, excellent. Now let us see fourth degree polynomial side. Maximum terms, how many are there? Maximum terms. So it is fourth degree, no? However, it's a degree 4 plus 1. So maximum terms 5. This is the way to list out the maximum terms in the particular polynomial. Suppose if I am asking maximum terms of fifth degree polynomial, 5 plus 1 answer, that means 6. The maximum terms of 10th degree polynomial, 10 plus 1, 11. Maximum terms in a 10th degree polynomial is 11. Last question. The maximum terms of 12th degree polynomial. Answer is 12 plus 1, nothing but degree of the particular polynomial plus 1. So you will get the maximum terms in that particular polynomial. That is the way. So similarly, nth degree polynomial, in this however minimum terms 1, maximum term side, yes, n. Why? Because it's a degree n, no? That's why n plus 1. What is this? This is what? Nth degree of the polynomial having n plus 1 maximum terms. Simple question, tell me. In a nth degree polynomial, number of maximum terms, tell me. N plus 1. Minimum 1. So, carefully observe. Every polynomial, whatever the polynomial, minimum terms however permanent, that is 1, 1, 1, 1, 1. But come to the maximum terms are changing, you know. Now tell me, maximum terms in the linear polynomial, it's a degree 1 plus 1, 2, right? Maximum terms of the quadratic polynomial is equal to, it's a degree 2, 2 plus 1, 3. Maximum terms of cubic polynomial is equal to, it's a degree 3, 3 plus 1, 4. Maximum terms of fourth degree polynomial is equal to, it's a degree 4, 4 plus 1, 5. Maximum terms 5. Similarly, maximum terms of nth degree polynomial is equal to its degree n plus 1. That means maximum terms of the nth degree polynomial is n plus 1. Right, students, listen. Okay. Okay, students. Now last sixth point, that is polynomials with two variables, mainly x comma y, and polynomials with three variables, that is x, y, z. Here we discussed the polynomials in one variable, that is mainly we focused x, we concentrated x variable. But now what happened? Polynomials with two variables, x and x comma y. Let us see few examples. Through this you can understand. X plus y. What is this? This is polynomial only. But how many variables are there? Two there. So title is also same only. Now polynomials we have to list out with the two variables, mainly x comma y. Now I want to give one more. X square plus y. Third one. X square plus y square. Fourth one. I think understand now. Next. Xy plus 5. Last one. Now x square y plus 9. So like this we can write many examples. These are polynomials which contains two variables, mainly x comma y. These are few examples. Let us see this side. So examples 1 6. Three variables involved now. Mainly x, y, z involved. Number 1. X plus y plus z. It is also polynomial only. Second. X square plus y square plus z square. Third example. X square y square z square, z square y square. Fourth one. So x square y square z. Last one. X square y z square. Like this we can write many polynomials which contains x comma y comma z variables. Okay, students. Okay. I think there is no doubt at all. Everybody understood these things. And mainly the polynomial with the two variables and three variables we will discuss in further classes, beta. Mainly in 9th or 10th we never discuss such type of polynomials. With the two variable concept, after 10th class you have to learn. Till 10th class you have to focus on the polynomial which consists just one variable. Okay, na? Right? And one more thing, nobody are sharing any doubts in my comment box. So if you have any doubt, definitely you share your doubts in the comment box. And one more thing, it is my request also, you like my videos and share my videos, as well as subscribe my channel, through that you will get direct notification from me. Okay, thank you.